To episode 5 of an introduction to Unity. In the previous episode, we discussed fields and methods and the other meaty parts that go into making our own custom components. We did so by looking at one of the components that makes our unassuming hero, Joshua Smashburn, avoid the mean pegs and reach the buckets below. Also, I named our ball Joshua Smashburn. But that obviously wasn't the only component. In this episode, I'd like to go over the structure of this project while exploring a few concepts related to C# programming. So let's get started with our boy, Mr. Smashburn. He has 5 components outside of the standard Unity ones: player health, player input handler, simple falling controller, simple movement, and damage flash. As I mentioned in the previous episode, each one of these is responsible for managing some aspect of how our hero behaves. Now, the process of deciding what deserves its own component is something of an art. There really isn't a wrong way to do it except the way that you did it last. Past you is almost always an idiot to future you. For me, components can typically be categorized into 3 types: handlers, controllers, and to round out the other inspired names, doers. These types can be mixed and matched, and if I find that a component could be categorized as all 3, then it might be a candidate for breaking up. Player input handler is, well, a handler. Handlers like this one are responsible for handling input and events. Their job is to take raw information, clean it up, and pass it along to be used by some other system or component. This one here just acts as a wrapper for Unity's input system, serving to contextualize raw input information like how fire 1 is considered a jump. Next we have the simple falling controller, which acts as our controller. Controllers are sort of choreographers. They don't really process input directly or handle completing a certain action. Instead, they act as glue so that the other components can remain ignorant of one another while still working together. In essence, it takes input and makes certain that the various doers are doing their doing without doing over other doers' doing. And you can see this here in the simple falling controller, which has a reference to player input handler, a handler, and a reference to simple movement, a doer. Each frame, it requests the input from the handler and then uses that with some internal information to decide what exactly movement should be doing and when. In this way, simple movement doesn't need to know about player input handler, and vice versa. Controllers are oftentimes less reusable than other components, but their job is not to be reused. It's to make certain that the other components can be. So let's move on to our first doer, simple movement. It's responsible for making Mr. Smashburn move. It does so by receiving information from whatever's using it through its move method. Then, in its fixed update, it will take that information, mixed with some of its own internal fields, and compute a new velocity for our ball. It doesn't question that information, it doesn't make second guesses, it simply takes it, transforms it, and applies it. Now let's move on. Wait, this fixed update looks a bit iffy. Not in that it's doing anything wrong, but it has several if statements and seems like a good place to teach you about them. If-else is one of the simplest forms of control in programming. An if statement takes a Boolean expression, something that ultimately equals true or false, and then forces the program down one of 2 paths based on the outcome of that expression. If the expression is true, it does the stuff contained inside of the if. If that expression is false, it does the stuff in the else. Else if allows you to chain more than 2 choices together. In this case, the stuff here will only happen if this expression is false and this one is true. If this one is true, then it won't even bother checking the else if. If they're both false, then it won't take either of these paths. The expressions used in these if statements can come in many forms, but they must always boil down to a true or false value. Comparisons are the most common type of expression, taking one value and seeing if it's equal to, not equal to, greater than, or less than some other value. But simple comparisons aren't always enough. Sometimes you care about multiple conditions when making your decisions, and that means you need a way to combine 2 expressions into one larger one. Luckily, we have and or. And will combine 2 expressions like this. or will combine expressions like this. And an or can be used together and work to make massive chains of expressions. Now let's move on to the next two, player health and damage flash, which are sort of hybrids. They're both handlers and doers, a reactive doer, if you will. Player health is responsible for maintaining the health of the character, responding to whenever it collides with one of our pegs through a take-hit method. And damage flash responds to changes in health, causing the ball to flash red briefly. So that's our hero. But he's not the only recipient of a fresh set of components. We also have these lovely UI elements. Let's take a look at our life bar, which responds to changes in health to show how many more hits we can take. It handles a health change event and responds by updating the number of hearts that appear next to the character. First, let's take a look at this thing, game object brackets. A weird way to define a field, huh? Well, it's not your typical field. In this case, we aren't defining a field that is a reference to a game object, we're instead defining a field that is an array of game objects. Arrays are ordered containers of several objects, in this case, game objects, and you can make an array out of any type simply by adding brackets to the end of it. And in most cases, you need to also initialize the array with a certain size. We're using this array to represent our hearts that appear next to the character. So in the start method, we'll initialize our array of game objects with a size equal to the starting health of our ball, like this, which will be 3. But we're not quite done yet. Our array exists, but it's not filled. Each slot in the array references no game object. So we need to set those slots equal to an existing game object. And this is where this for loop comes in. C# has several types of loops, which allow us to do the same thing multiple times. The for each, the while are the most common types of loops. There's also a do while, but I'm not going to talk about that because it's super rare and no. For loops are good at doing things a known number of times. They follow the format of defining the counter, checking the counter, and then changing the counter. In this example, we define our counter as the integer I. Then each time we check if I is still less than the size of the array. If it is, then we do all of this. And once we've done that, we go back up, increment the counter, and check to see if the condition is still true. And we go through this process over and over again until the condition isn't true anymore. And then we can move on. Inside this loop, we'll make a game object using this instantiate method, and then assign it to a slot in the array. Array slots can be accessed by taking brackets and an index. The index corresponds to the slot that you want. You want the first slot, that's 0. You want the second slot, that's 1, and so on and so forth. So by using I in brackets while in the loop, we can automate the process of setting the value in the slots. The first iteration of the loop I will be 0 and will fill the first slot. Then we'll increment I, check the condition, and re-enter the loop, but this time I will be 1 and will fill the second slot. We'll do this again with I as 2 and we'll fill the third slot, and finally we'll increment I to 3, check the condition, which will fail, and exit the loop. Loops like this one and while loops are very similar to if statements in that they check a condition, and if it's true, you do the stuff inside. But if it's false, you don't. Loops just keep going over and over again while that condition is true, while ifs will move on. The other type of loop, for each loops, are a little different though. For each loops are actually just nice for loops under the hood that allow you to go through a collection of objects without having to write out the brackets and everything. They're easier to understand if you read them aloud. For instance, I want to call setActiveFalse on every heart in my array of hearts. This is the same as doing something like this, but with a little less visual complexity. Where for each loops actually differ is that I can't change the contents of the array while I'm looping. I can't set heart equal to something new or null it out like I could heart index I. That's just not allowed. I can only look at or call methods on the heart, which can be a little annoying, but is also a nice safety blanket to keep you from doing something that maybe you shouldn't be doing. Phew. Well, we're at 10 minutes. I warned you in the last one that this might get a little dense. I didn't even get a chance to tell my usual number of bad jokes acted out through After Effects animations, which is unfortunate if you are new to the series. Component construction and the usage of more complex control flows like loops and if statements will take some practice. But I'm confident that if you stick with this and you go through this project or other people's projects, probably other people's projects, or of course start making your own, you'll gain the confidence and experience to understand what I've talked about in this series to make your own really cool games. Things that I'm very excited to see for myself whenever you get them finished, because of course you'll send them to me, we're good friends now. When I started working on this series, I very much wanted to teach the basics of how to use Unity in C#, and in some ways I feel like I've nailed that. In several others, however, I feel like I'm very far off and maybe have even led you in the wrong direction. Take everything I've said with a grain of salt. Either way, there's so much still to go over, even within this simple project, and I won't be going over it. This series has taught me a lot about my ability to make videos like this, and I hope that it has been helpful to anyone that is trying to get started in Unity. But I'm going to take a break from these for a tick so I can focus on my actual work, which is spinning up fast. And also making gameplay videos with my wife, because it's a much needed reprieve from my actual work. I really appreciate anyone who has watched the whole series, and I plan on revisiting Unity tutorials in the future, now that I kind of know what goes into them. As always, please like and subscribe for more of my sweet voice and life advice, and always leave a comment if you have any questions. I'm always happy to try and help. For the last time, for a little while, I'm a person, and thanks for watching.